Welcome back, everyone. So, like I mentioned in the previous video, we have discussed the Spark and the SQL to get the expertise on the data engineering field. What we're gonna do now in this video, we'll go into the lab environment and we'll see how the SQL and the SQL and Spark play its role in the data engineering field. So that will really help you to understand how the whole environment work and what we are expecting in the day-to-day job of the data engineer. So let me just spin up. One thing which I would like to share with you, like you can see at the moment, I'm in the Linux environment, and that's the beauty of working within the cloud environment. Traditionally we are limited with the technology that we are using, especially with the Microsoft. I'm not talking about non-Microsoft, because non-Microsoft technologies, they are more flexible in terms of working with them. But with Microsoft, it was like a limitation. You have to have the Windows operating system, and then you have the specific tools that need to be installed on your machine. Now with the advent of Azure, all those limitations are gone. Now imagine, if you remember, I worked on the server where I have the local environment, and my local SQL server was still installed there, and I still have all the data sets in there. But the beauty of the cloud environment is that now my data, which is in the cloud environment, is available anywhere where I want to use it. So let me show it to you. Like, I can actually come in here, and that's my same database which I have actually created in previous video. And you can see I can log in, and I can go and you know I can just run my query through the web interface. But it might not be impressive, because web interface, like many others tools, they are providing the web interface capabilities. By the way, that's our first statement that we have run against SQL environment. I'm going to come back to the introduction of the SQL and the Spark in a moment, but just want to show you how the dynamics of data engineering, and all the data related technology, how they are changing, how we are getting more and more flexibility to work into multiple environment. And like I mentioned, you can see I'm within the Linux environment. So my operating system at the moment in the virtual environment is Linux. It's not like I'm sitting on the Windows machine. So for me, wherever I'm working, I have my data available and I can use it. That's the first thing. The second thing, obviously, the flexibility of the tool, that Microsoft has took a big step to release its tool on the non-Windows operating system. And like I mentioned, Azure Data Studio, that is now available on the Linux and the OS operating system as well, on Apple devices as well. Like, you can go and you can download it, and I can see I've already downloaded and configure it, and the same database is running in here. So you can see I'm already connected with the cloud environment. Like, if I come in here, that's my interface which I have used to connect to my cloud instance, cloud database, and you can see all these tables are there. And now I can run the similar queries which I was previously running in the cloud environment. I'm able to run the same query within the Azure Data Studio. And Azure Data Studio has a lot of feature, like it comes with the IntelliSense, and you can run all sort of queries, which is really a powerful feature of this tool, right? It is not restrict you to running Windows operating system. Now you are wherever you are, whether you are on premises, whether you're on laptop, or whether you are in the cloud, anywhere you can run your queries or scripts. Now, by saying it, let me first show you a very first query with SQL. SQL, like I mentioned in the previous video, our SQL is based on the structure data set. That's why we call it structured query language. Like it's normally used to handle the structured data set. But now that term is changing slowly, because what you're gonna see very soon, once we work with the non-SQL data sets, we're gonna use the SQL interface to write our query. You're gonna see the select statement the same way. The only fashion is going to be changed. Like instead of we are using a typical normalized data set, which is in the tabular format. We're gonna use the semi-structure where we have the denormalized data, and it is containing the multi-value attributes. So all these things which can actually express or help us to express the joins between different entities. We can use non-SQL databases to do that. And like I mentioned in the previous video, if once we work with Azure, we're going to work with Cosmos DB, and once we work in the AWS, we're going to use the DynamoDB. Both are great products and both provide great feature for the non-SQL capabilities. Now, right now, what we are going to do, let me just make a very simple statement: select and from. And if I just put star means everything, right? So every tool has its own. I think that's the tool. Yeah. What's a simple SQL statement? Yeah, I think that's the. I just put a command, and you can see the simple selection, because most of the time what we are doing, we normally select the data. Keep in mind, until unless we enter into the data warehouse environment, we are not going to insert the data. But most of the time, especially once we are building the analytics and report, we normally retrieve the data, and the language or the statement that we use a lot to retrieve the data, that is the select statement. So you need to, that's the very first rule you need to learn, that whenever you need to get you need to get the data from the database, you need to run the select statement, because select actually tells the query engine or the database software that okay, the request is to retrieving some information, right? And where that information is coming from, obviously we have some sort of table structure that is a tabular format. And once I say table means it has some rows and it has some columns. So you can see these are my rows. These are my rows. So you can see these are my rows. For some heart, just keep going at the end. And these are my columns. And wherever these intersect, that becomes one of my data point. I would say, sorry, one of the element of my data point, because that is the data point. Let me just also keep updating you, or keep telling you that what the data point is, because once we enter into the machine learning world, our language is going to change from the rows and tables to data points. And one data point is actually nothing but a row. And that row can have single attribute row, or it can have multi attributes or multi value attributes row. We are not going towards the complexity. Right now, we keep everything simple, right? So you can see each row is representing one data point in our space, where we have unlimited, attribute or dimension. And sometimes we call it dimension as well, because once we start manipulating the data to in terms of machine learning modeling, the terms change from one language to another. But underneath, once you start looking into it, that all refer to the same thing. All right, so that's a very quick introduction of the first statement that we have seen. Whenever you want to run select star means all the column, you want to run all the column, and then the from clause that mentioned that where you want to get the data. So after from, you always send the always mention the table name. So if I actually just put a generic statement, so it's going to be SQL star. Let me just put simple for all columns. Put equal, otherwise gonna do all the crazy thing from event, right? So that's a general syntax that we normally use, right? Or obviously, like I mentioned, for all columns, you can use star. So that's the select statement. So you can see how we extract the data that has been stored into our tables. And obviously in this course, especially from the data engineering, you're going to see lots and lots of requirement to extract the data. And like I mentioned, I'm not going to talk about the data warehousing and the analytics at this point. At this point, just remember that we have the data, whether it's the data is sitting in a plain table, or it is sitting maybe in a dimension, or maybe it is sitting in a fact. What dimension, fact, and normal tables are, what are the difference? If you don't understand, don't worry about it. We're going to actually look into detail in the upcoming videos. So that's the select statement or SQL side. And we keep in mind we are using Azure based SQL environment. All right. So now we are shifting our gears towards another side of the world, which is based on Spark. So I'll try to upload another video that can actually describe the different option and the introduction of the DataBricks, because for this Spark work, we're going to use the DataBricks free community edition, and you can you don't need to download, you can register it and you can use it. It provide you 15 gigabyte memory cluster with 2 cores, which is more than enough for us to run any kind of dev scenario. Because obviously once we start understanding how the DataBricks work, we obviously move into the actual environment, the actual dev environment. The beauty with DataBricks is available with all 3 major cloud providers, the Azure, AWS, and Google. So you learn one thing and you have the opportunity to apply on all the cloud environments seamlessly. How cool it is. What we're gonna do in this demo, we keep the thing simple. Obviously, I'm going to use the Spark Scala language, where the Spark has been the language that has been used to develop Spark. So we have the Python interface as well, which we call PySpark, and we have the SQL interface as well. In this series, I'm not going to touch Python. If you like to use Python, I'm going to actually record a separate video series for that. But I think two technologies are more than enough to you to absorb within one series. So let me first come why people don't like Spark, because the statement looks a bit ugly compared to Python or other language. Like we normally not used to declare like full namespace like this, like you can see. But tell you the truth, there is no complete. Once you start understanding Scala and its working, its library or structure or working structure, everything looks normal, right? It's more like a hype at the moment that okay, yeah, it looks difficult. It's very ugly. We don't like it. It doesn't seems to be similar to existing language where we have more like from Python import import pandas, and from math import all the functions or classes that can help us, right? Trust me, within this Spark, although it looks a bit ugly, but once you understand, you are going to have lot of power under your belt. And the reason behind it, because this is a pure distributed application that work on multiple cluster that handle your code, and then it distribute the code automatically based on the number of cluster that you have, number of server that you have defined within that cluster. By saying it, let me quickly come towards the cluster. So you can see we have the one cluster, which is a pre-cluster, and you can only have one server in that cluster. You cannot increase node. What nodes are, what the cluster is, if you don't understand, don't worry. This is more like a very first demo, which is linked with the first video that I've actually recorded for the intro of the course. That's why I'm not going into the detail, but these are the things we're gonna see later in detail, so it can help you to work with this Spark as well. Coming back to my workspace, let me just go in here, yeah, I can come in here. So like I mentioned, you can see we have Scala, but we can change the default language to SQL, Python. And oh, by the way, if you know R, you can use R as well. R is more like a very high level language, which doesn't provide you deep capabilities to do the programming, but it's a very powerful and I would say RAD tool, rapid application development tool, that if you understand R, literally you can use R against the DataBricks as well. So that's something really amazing. Like all these languages has been integrated, and they can provide you the capabilities of building distributed application, which was previously, before Spark or before DataBricks, is more like a very limited had very limited audience who were actually using it, and it was not in the market, because theoretically previously, like a decade before ago, we don't have these big data sets available like we do have now. So I'm going to stick with Scala. So how it works: org.apache.spark. Just imagine it's more like a hierarchy where we have one major namespace which is inheriting a subspace which is inheriting another subspace, and obviously all these subspaces, they have some sort of classes or other namespaces which contain more function. What I'll do in the later video, I'm going to actually show you the namespace hierarchy in the Spark documentation, so you can understand how these hierarchy works and how they have been built. Because once you understand it, then it will be very easy to get the information, to get the right function, and then use it into your code. So that's how we declare it. Let's understand it, second import statement. So like I mentioned, that's the major space, and then we have the subspace underneath, and then we have another subspace which is Spark, which provides some additional function and procedure that you can use to to execute the calls that has been pre-built for you, right? So it's not like you are going to build anything new. You can utilize a lot of modules, a lot of functions that have already been built for you. What does it mean? We're going to actually see shortly. Obviously, we are going to use SQL, so we are including or importing this SQL library. In another term, we call the namespaces as the libraries as well. So these are all nested libraries which provide you the capability to call the function which have been pre-built within these libraries, so you can execute, you can use and execute into your program. Now, I'm not going to go towards these are more like some basic code which I built, and I'm going to explain them into its due video. Let me come in here where I'm actually loading the same person table. So what I have done, just to make things clear, so you can see, it would be much easier if we have the similar data on both sides. So now imagine we are using the same person in here, right? We have a person table in SQL Server, which is a structured database. On the other side, we are loading the same person information. Obviously, it's in the CSV, and with the Azure Data Studio, you have the beauty. Once you run the outcome, you can export it. Like you can see, there's a small button in here. Excuse me. You can export it or save it as CSV, whatever the outcome is. You can export it as a Excel, or you can export it as a JSON, right? So all these formats are natively available. Let me see, I think XML, yeah, no, I don't think it provides you the Parquet file. That's all right. We can use Spark to convert into Parquet. Okay, so the very first statement, wall, that has been used for declaring the variable. You know, in some languages we have particular expression that mention to the compiler that okay, that's the variable which is containing some value. So always remember, wherever you're gonna see the wall, VL, that means that that is declaring a variable that we're gonna use into our code. So obviously we have declared a couple of variables into our file, and like you can see, this file is going to store into my DataBricks file structure that has been provided, because our cluster is running more like on a server, and that server has some file system where our files are going to be stored. So it's not like we don't have the permanent storage capabilities. Once you get the cluster, it comes with the storage space, so you can load and save your file there. And even once you process your file and whatever the outcome is going to be, you can convert into Parquet or any other format, and you can store it again, so you can later on retrieve it or use it. File type is CSV, because like I mentioned, we have converted into the CSV. Infer schema is the opportunity, is the intelligence that actually let the Spark engine to identify and you know, mention the data types of your column. So look at the data within the column, and then it recommend. So infer means it recommend the data type based on the value or the data which is sitting within the data set or table. In our case, because we know what the data types are, that's why I'm putting it as a false. Obviously it's can be true or false, but if you are going to put it false, then you need to mention your data types. First row is a header, which is very common, and I think most of us, we know that whenever we import the data from CSV, always the first row is always referred to the column name, because if you don't have those column names in the first row, then Spark automatically assign a series of column which is underscore C0, C1, C underscore C1 underscore C2 up to underscore C, and depends upon the number of columns. And obviously, last but not the least, we have the delimiter, because obviously CSV comes into different delimited format. Like we can use pipe sign, we can use semicolon, and we can use comma. Cool. So let's go and let's spin up our first command. Now it is processing, and that's it. It's done. Like you can see, the speed is pretty awesome. Like we have 0.92 second. Okay, the next statement, we are going to read the file and we are going to load our file structure into our data frame. Now, data frame is more like the backbone of Spark or the data analytics engine. Although we are talking about semi-structured, unstructured, and you know, structured data set, but obviously we need something where we can store our data set. And you know, normally, tell you the truth, we use two-dimensional structure to display our data, because or to work with our data. And the reason is working with two-dimension is the only possibility that we can show. Now we have obviously three-dimension visuals as well, which we can use to display the three-dimensional data. But you know, beyond that, it's still not the possibility. I know the academics is heavily working on these areas, but that's the most commonly, you know, pattern you're gonna see within the industry, right? So whenever we have our Spark notebook, the very first thing we need to get the data. Like I mentioned, we need to provide the source, and then we need to load the data into our data frame. And all I did, this more like a syntax. We have the spark.read.format command. Don't worry about it. If you don't understand, I'm gonna go through one by one with each and every command in its due video. I know it's a big job. And then once we know that our data frame is ready, just for the, in like in the, let me see if I remember correctly. I always confuse with the, we don't have it in here. What I'm gonna do, print schema. Okay. All right, yeah, it took some time, like I mentioned, because I'm working with the Cloud SQL and I didn't have much power because I'm using the free version. One thing keep in mind, guys, that sometimes you're gonna see performance issue because I'm using a free service which provide me one database, one SQL database that I can use with the limited resources. Like it's not like the on-premises environment where we have heavy server which is running our database server, and then we can spin up the queries and we can run it with the cloud. Obviously that's the way all the cloud vendors, they are making money, that if you need more power, if you need more resources, pay for it, and then we'll increase or scale up, or you can even go and scale up by yourself, right? But with the free tier, obviously there are restriction, otherwise who's gonna buy the actual service? But so by saying it, you can see that that's the structure that we can display within the SQL environment. The same thing we can print it in here. Like you can see, we have the business entity string, person type string, and then I think we don't have numeric in this data set, but we do have we're supposed to have the modified date. Anyway, I'll check it later, right? Because modified date, it is reading as a string, but it's theoretically it should be date type. So we'll see later on how we can change the column data type. And now we are all good. So what we're gonna do, we're gonna actually select very first thing what we are going to do. We are going to do first select, and in here, like I did for 3 columns, we can mention all columns. And let me do one thing which I do believe work in here as well, and see. There we go. So the same thing. Now that's where you need to understand the difference between the Spark and the SQL. Spark providing you the same language, which can do the same thing, but it has its own syntax. So the difference is only syntax. Once you build the logic, your logic is going to work with SQL as well as Spark. That's why we are actually looking both work side by side. Now you can see I select the top 10 result and I bring all the columns. And let me go back and let me show you in here. Oops, open the wrong application. What it's going to do, the same thing if I want to run, that's the SQL side of the same thing. And you can see Ken J, I do believe we're gonna have Ken J on the other side as well. There we go. You can see Ken J is on the top, and because that's the behavior, that's a query engine behavior, because behind the scene there is an analytic or query engine that is running, which is converting based on your requirement. So that's how we work within the SQL and Spark. Two different languages, but work in a same way, or so work towards the same target, or towards the same requirement, right? Obviously in upcoming videos we're going to see more and more example. We're going to go through all all mostly all the major commands which have been used in the industry on day-to-day basis. And I assure you that after this course, you're gonna be a confident data engineer who can go and who can perform really well in any kind of data engineering interview and get the job. So if you like, please like the video or subscribe the channel, and I'll see you in the next video. So thanks for watching.